Hey guys, in this next video we're going to look at how to solve equations with square roots. And so that's going to require us to first of all look at a new inverse operation. So when you have a variable that is squared in your equation, okay, for instance an x squared, in order to isolate that variable you can take the square root of both sides to solve that for that variable. So whenever we have a squared variable, the inverse operation is going to be square roots. A square root will undo an exponent of 2 in your equation. One thing we need to watch out for, though, is when you have these types of equations, oftentimes you have more than one solution. And so we'll talk about why that is and how to write those solutions then. Okay, so this is a similar process to what we've been doing. You're going to locate the variable. You'll isolate the x squared or m squared or whatever the variable might be. Okay, get that by itself. Once you have the x squared or whatever the variable is, you take the square root of both sides of the equation, and then of course at the end you want to make sure you're checking your solutions. So number one, we have x squared equals 36. The x squared is already isolated, okay, so that takes care of steps 1 and 2 in my process up here. So now I'm just going to take the square root of both sides of this equation. And so I'm going to show that by doing my square root sign here and here. When you take the square root of something squared, the square root of x squared, you just get x, because again the square root and the exponent sort of cancel each other out. So I get x equals, when I take the square root of 36, I have to be careful. I have to think to myself, what number can I square to get 36? Well, there's actually two possibilities. If you square 6, okay, we know 6 squared, 6 times 6 is 36, so that's of course the possibility most everyone thinks of. But there's actually a second possibility. I can also square negative 6. Negative 6 times itself is positive 36. So when you're solving an equation and using square roots to solve that, there are actually two possibilities for your answer here. You have positive 6 and you have negative 6. And we show that in our answers by using what's called a plus minus sign. It looks like this. And this just represents that we could take the positive or the negative of this number 6. So this means that there are two solutions to this equation. Positive 6 is one, and negative 6 is the other. Oftentimes when we have more than one solution in an equation, we will write those solutions in braces. So you might see your answers written like this. Okay, this just means that the two solutions for this equation, the two numbers that make this equation true for x, are positive 6 and negative 6. Okay, let's try that for number 2. We have 121 equals m squared. So m squared is already isolated, so that means I can take the square root of both sides to undo this exponent here. So that gives me m equals, the square root of 121 is 11, but remember I need to include that plus or minus sign to represent my two solutions. So this is going to be plus or minus 11. So two answers for this problem, positive 11 and negative 11. Number 3, a squared equals 0. Again, I have my a squared isolated, so I can take the square root of both sides. So I get a equals, the square root of 0 is just 0, and 0 is neither positive nor negative, so I don't include a plus or minus sign here just because that doesn't make any sense. 0 is just 0. So I have one answer for this problem, and that answer is simply 0. Okay, number 4, r squared equals 196. Again, take the square root of both sides, and you get r equals, if you remember those perfect squares that we talked about at the beginning of the year, 196 was on your list. 196 is equivalent to 14 times 14. Okay, so the square root of 196 is 14. and you're going to put a plus or minus 14 there. If you forget that, you are allowed to use a basic calculator for these lessons, remember. So you can always type in 196 and then hit the square root button on the calculator, and that will give you the 14. You just have to remember to include the plus or minus sign in your answer. So two solutions, positive 14 and negative 14 here. Okay, let's get to some more challenging equations. Number 5, x squared minus 10 equals 39. So in this equation, notice that your variable is not isolated. So we have to use our other inverse operations to first of all isolate x squared. So I see a subtract 10 here. I'm going to use addition to undo that subtraction. So that's going to give us x squared equals 49. From here, now I can take the square root of both sides of this equation. So this gives me x equals, the square root of 49 is 7, so plus or minus 7. So my two solutions are positive 7 and negative 7. For number 6, 192 equals 3w squared. So the first step would be to isolate the w squared. This is multiplication here, 3 times w squared. So I divide to undo that multiplication. 192 divided by 3 is 64. So I get 64 equals w squared. I then take the square root of both sides, and that gives me w equals, the square root of 64 is 8, so this is plus or minus 8. So positive and negative 8 are your two solutions. Number 7, 341 equals p squared plus 52. I find the variable. I'm going to isolate that by using subtraction. (341 minus 52 gives me 289. So this becomes 289 equals p squared. I take the square root now of both sides. 289 was also on your perfect square list, but if you forget that, again, a basic calculator would tell you that the square root of 289 is 17. So plus or minus 17 are your two solutions to number 7. Number 8, negative p squared equals negative 324. Remember, a negative sign by itself in front of a variable just means you need to divide by negative 1. So if I do that, I get p squared equals positive 324. And then taking the square root of both sides, p equals, the square root of 324 is 18. So positive and negative 18 for our two solutions here. Number 9, 81n squared equals 16. So I need to isolate my variable by dividing by 81. Notice what happens here. My 81s cancel and I get n squared equals, I get a proper fraction, 16 over 81. I can take the square root of fractions, okay? I can, even though this is not a whole number here, you can still take the square root of fractions. Fractions have square roots. And what's nice about this is when I take the square root of both sides in my next step, the numerator of my fraction is a perfect square, 16 is a perfect square, as is 81. Okay, so to do this, I just need to take the square root of 16, which I know is 4, over the square root of 81, which I know is 9, and so this becomes plus or minus 4/9. Your basic calculators won't do the fraction for you, but they will do the 16 and the 81 for you, even though you shouldn't need those, since 16 and 81 are in your regular times tables. So plus or minus 4/9 for your answer here. Number 10. Okay, this is going to be a few more steps than the previous ones. So I have negative 4a squared minus 37 equals negative 137. So I have a couple of things I need to do before I can even start doing my square roots. I need to isolate a squared. So I can do that first of all by undoing my subtraction here. I need to add 37 to both sides. And so that gives me negative 4a squared equals, this would become negative 100. Don't forget your negative signs here. And then I need to divide both sides by this negative 4 to isolate the a squared. When I divide negative 100 by negative 4, I get positive 25. So now that we have a squared isolated, we can take the square root of both sides, and I get a equals plus or minus 5. All right, two more we're going to try. Number 11, w squared over 3 plus 21 equals 48. So first step is to undo the addition with subtraction. So we'll subtract 21 from both sides. That leaves w squared divided by 3 equals 27. I have division here, so I need to undo that with multiplication. So I'm multiplying both sides by 3 to get w squared equals 81. And then finally, I'll take the square root of both sides. The square root of 81 is 9, so this becomes w equals plus or minus 9. Okay, for this last problem here, I actually have a typo in your example, so you need to change this 34 here to a 54. So go ahead and change that for me, and we'll solve this last equation. So to solve this equation, I need to undo subtraction first, so I'm going to add 54, now that we've changed this, to both sides. And that's going to give us 4v squared equals 49. From there, I can divide both sides by 4, and I get the improper fraction 49 fourths on the right side. V squared equals 49 fourths. So we have the same situation here as we had in number 9. We're taking the square root now of a fraction. 49 and 4 are both perfect squares, so this becomes v equals plus or minus 7 over 2. So remember, square root of numerator over square root of denominator will give you your answer in those cases. Okay, if you had any questions over this video, make sure you ask those the next time you're in class. Until then, have a nice day. You're all wonderful people. Take care.